There are three ways that we can solve a linear system. We could graph the two equations and look for the point of intersection visually. We could solve the linear system using the substitution method, or we could solve a linear system using the elimination method. Now that you might be well versed with both the substitution and the elimination methods, we could take a look at solving different problems by either using substitution or elimination. In order to solve problems of this type of nature, you need to be able to model this situation with equations. And remember that linear systems are always made up of two different equations, and then those equations, you can use them to solve for the point of intersection. So we're going to take a look at four different types of problems that you could come across, and we will learn how to model the scenarios or the situations with two linear equations, and then we'll solve each question either using substitution or elimination. In the first problem, Alan earns an hourly wage plus tips. 1 week, he worked 12 hours and made a total of $117. The next week, he worked 10 hours and earned the same amount in tips as the week before for a total of $110. What is Alan's hourly wage? Before we can even come up with two linear equations, the first thing we need to do is pick or identify variables that we're going to use to model this situation. Now, it doesn't matter what letters you choose to use. If you're comfortable only working with X and Y, then you can choose to use X and Y. Or if you want to choose different letters to match the story or the problem, you could totally choose to do that as well. So when we read through this problem, there are two things that we don't actually know. The first thing that we don't actually know is how much does Alan make per hour? And that's really what the question is asking us to solve for. It's asking you to identify what is Alan's hourly wage. So how much does he make per hour? The other thing that is mentioned and that we have no idea about is the amount of tips. It says that he earns an hourly wage plus tips. Okay, he tells us how much he earns every week, but they don't specify the amount of tips. In fact, for the second week, they just say that he earns the same amount in tips. But we need to know what that amount is in order to figure out or understand how he gets these totals. So knowing this, I can now pick some letters that I'm going to assign for these two missing quantities. So I'm not going to use X and Y, but if you, again, want to use X and Y, you can. I'm going to say, let H represent hourly wage, and let T represent amount earned in tips. Now that we've identified what variables we're going to use, we can take those variables and start to build our two equations. So my first equation is going to represent the first week. So in the first week, it tells us that Alan worked 12 hours and he made a total of $117. Now, it doesn't explicitly say that he earned tips, but it does tell us in the very first sentence that he normally does earn an hourly wage plus tips. So if I'm going to take this information and translate it into a mathematical equation, I could say 12H plus T is equal to 117. So what this tells me is that he worked 12 hours multiplied by whatever he earns per hour, and we don't know what that quantity is, plus whatever amount he earns in tips. All of that together is equal to $117. The second equation in our linear system is going to represent or model the second week or the next week. And the question tells us that Alan worked 10 hours and he earned the same amount in tips. So if I translate that into a mathematical expression, it's going to be 10H plus T, which is equal to 110, because we know that he worked for 10 hours. He gets that same hourly wage. He gets the exact same amount in tips, so it's also going to be modeled by T, and all of that has to equal $110. So now you have your two equations which make up your linear system, and as always, we always number our equations, equation number 1, equation number 2. And from this point, it really is your choice. If you prefer to use substitution, you can take these two equations and solve for H, the hourly wage, using substitution. or if you prefer to use elimination, you can use elimination as well. By looking at my equations, I see them stacked very nicely on top of each other, and I also notice that both equations have the letter t. So to me, when I look at this, I think it's going to be really simple to solve it using elimination, and so I'm going to go ahead and solve for h, the hourly wage, using elimination. So if I want to solve for h, that means I need to eliminate or get rid of the letter t. So I have a 1t in my first equation and a 1t in my second equation. So I need to decide if I want to either add or subtract the equations in order to eliminate the letters t. So I know from using a little bit of mental math that if I subtract the equations, I will successfully be able to eliminate the letter t. So I'm going to go ahead and do that subtraction starting from the far left. So I'm going to start with 12h subtracted by 10h, which would give me 2h. And then I move on to the t's. So t minus t, that is 0. And so we've successfully eliminated the letters t. And then I have an equal sign. And then I have 117 minus 110, which is 7. So now I am only left with the letter h to solve for. And so to isolate for the letter h, I'm going to divide both sides by 2. And so that will leave me with h is equal to 3.5. Now I can stop here and I don't need to go back now and take this answer and put it back into equation number 1 or number 2 to solve for t, because the question, remember, is only asking you to solve for Alan's hourly wage. They didn't ask you to solve for the amount that he earns in tips. So this answer is going to be the final value for our hourly wage. So if I write a concluding sentence, I can say, therefore, Alan's hourly wage is, and I can't just leave it as 3.5. I need to make sure that I'm expressing it as a money value. So his hourly wage is actually $3.50. Another type of problem that you could see involving linear systems requires you to use your knowledge of angle properties and angle relationships. So this particular question just does that, and it asks you to use your knowledge of angle laws to solve for x and y as indicated in the diagram. So we have two lines marked A and B, and they are being cut through by a transversal. And then we've got some marked angles and some marked information. So let's start with angle number 1 and angle number 3. These are angles that are opposite from each other. And in math, angles that are opposite from each other, they are equal to each other. So I'm going to write that down on the side here. So I know that angle 1 is equal to angle 3. So that means the expression x minus 2y, which is located next to angle 1, that is equal to the expression x plus y, which is located in the position of angle 3. So I'm going to go ahead and mark this equation as my equation number 1. To come up with my second equation, I'm going to look at the information that's given to me in the positions of angle number 3 and angle number 6. So angle number 3, as you know, is labeled as x plus y, but angle C is actually given to us. They tell us that that particular angle is 115 degrees. And if you think back to some of our angle properties, we know that anything that's enclosed in what could be called a C pattern, or it could be referred to as a co-interior angle, these two angles here in the positions of angle 3 and angle 6, if we add them together, they should add up to equal 180 degrees. So let's write that down. We can say that angle 3 plus angle 6 has to equal 180 degrees. So that means x plus y plus 115 has to equal 180 degrees. So this is going to be our equation number 2. So we've come up with our linear system, and now this one isn't going to be so pretty, and it's not going to give us a nice setup that would go well with the elimination method, but this problem actually works quite well for substitution. And so what I can do is take one of my equations and rearrange it so that I isolate for one of the variables, so either the letter x or the letter y. So when I look at equation number 2, it looks like an equation that I could easily do that with. I could either isolate quite simply for letter x, or if your preference is to work with letter y, you could do the same thing for letter y. So I'm going to choose to isolate for the letter x. So if I want to isolate for the letter x, that means I need to take this y and bring it over to the right-hand side, and I need to take this 115 and bring that over to the right-hand side. So if I were to do that, that would leave me with x is equal to 180 minus y minus 115. And then I can collect like terms, and I can put together the 180 and the minus 115. And if I do that, I would be left with x equals 65 minus y. So I'm going to mark this as equation number 3. Now I'm ready to actually do the substitution. So I'm going to sub equation number 3 back into equation number 1. Now remember the equation that you rearranged and created, so for us that's equation number 3, you have to make sure that you actually substitute it back into the equation that you did not touch at all. And so for us that would be equation number 1. If you put equation number 3 back into number 2, you're basically just taking the same equation and putting it back into itself, and that's not going to give you a proper solution or a proper answer. So I've recopied equation number 1 onto my page, and now I'm ready to do the substitution. So everywhere I see the letter x in this equation, I'm going to put in 65 minus y. And then I've got minus 2y, I have an equal sign, and then I have another letter x, so I need to substitute here as well. And now it's just a matter of collecting some like terms. So on the on the left-hand side, I have 65, and then I have like terms with negative y minus 2y. So I can put those together, and that's going to give me negative 3y. And then on the right-hand side, I have 65, and then I have negative y plus y. Those are like terms again, so I can put them together. But negative y plus y is just 0. So those are going to cancel out. So now if I want to isolate for y, I'm going to take 65 and bring it over to the right-hand side. So that's going to leave me with negative 3y equals 65 minus 65. Okay, that works out to be 0. And then to isolate for y, I need to divide both sides by negative 3. So that actually nicely works out to give us y equals 0. So now that we have the answer for y, we need to go back and solve for the x. So it is your choice. You can take your answer and substitute it back into equation number 1, equation number 2, or even equation number 3. It is completely your preference and your choice. So since it's set up so nicely for me, I'm going to substitute y back into equation number 3. And so equation number 3 was x is equal to 65 minus y. And so 65 minus 0 is just 65. So we have our answers for x and y. X is equal to 65 and y is equal to 0. Another common type of word problem involves the use of percentages. In this problem, Giselle needs 200 grams of chocolate, that is 80% cocoa, for a cake recipe. She has one kind of chocolate that is 99% cocoa and another kind that is 70% cocoa. How much of each kind of chocolate does she need to make the cake? So I'm going to start by identifying the variables that we're going to be using in this problem. And what I see in the question is that there are two types of chocolate. We have a 99% cocoa, and we also have a 70% cocoa. What I don't know, however, is how much of each of those types of cocoa I need to blend together to make this cake recipe. So those are going to contribute to my variables. So I've chosen to say let X represent the amount of the 99% cocoa that I need for this recipe, and let Y represent the amount of 70% cocoa that I need for this recipe. Giselle tells us in the question that she does need 200 grams of chocolate in total. So I know that the amount that I need for the 99% cocoa plus the amount that I'm going to weigh out of the 70% cocoa, those two amounts put together have to equal a total weight of 200 grams. So that is going to contribute to my first equation. So I can state that X plus Y has to equal 200. So the amount of the 99% cocoa plus the amount of the 70% cocoa has to have a total weight of 200 grams. So that's going to be equation number 1. Equation number 2 is where we're going to incorporate the percentages. Now, in math, we typically don't use percentages as is, so we're going to have to instead convert them into decimal values. So 99% can be written as a decimal as 0.99. So in equation number 2, I'm going to say 0.99 multiplied by X plus the 70% cocoa, which could be written as 0.70 multiplied by Y. Together, that has to give me 86% cocoa, and the total weight of chocolate that we're going to be using is that 200 grams. So I need 200 grams in total, but that needs to be a blend of 86% cocoa, which can be written as 0.86. So I can simplify this a little bit by multiplying 0.86 by 200. And 0.86 multiplied by 200 is 172. So in fact, this equation is going to be the one that we call equation number 2. So we have one equation that represents the weights or the amounts of cocoa we are blending together to get a total weight of 200 grams of chocolate. And the second equation incorporates the percentages of cocoa and the weights that need to be blended together to get 172 grams of chocolate that is only 86% real cocoa. So looking at these equations, I see that I have decimal values built into equation number 2. And decimal values are not really the nicest or easiest to work with when we are using elimination, because we would have to multiply one or both equations by a decimal value. And so to avoid that, instead, we are going to solve this particular problem using substitution. And so I'm going to start with equation number 1. And I'm going to rearrange it to isolate for either your choice of X or Y. So I'm going to go ahead and isolate for Y. And so if I were to do that, that would give me an equation of Y equals 200 minus X. And so I'm going to call this equation number 3. So to begin solving, I'm going to sub equation number 3 into equation number 2, and I'm going to solve for the variable X. So if you'd like to try this on your own, go ahead and hit pause, figure out or solve for X, and then you can come back and to check your answer with the rest of the video. So once you go ahead and sub equation 3 into equation 2, you're going to use the distributive property to simplify 0.70 multiplied into 200 and multiplied into negative x. So that leaves you with 0.99x plus 140 minus 0.70x. I collected like terms, so that simplified down to 0.29x plus 140 equals 172. And then I collected like terms again by bringing the 140 over to the right-hand side. And then I isolated for x by dividing both sides by 0.29. So that left me with an answer for x of 110.3. Not an exact answer, but we're just going to round it off to the nearest tenth. And then once we have our answer for x, we can go ahead and solve for y. So I did that by substituting my answer for x back into equation number 3, since equation number 3 was already set up to solve for y. So by doing that, I ended up with 200 minus 110.3, which left me with an answer of y equals 89.7. So now that I have my answers, I can go ahead and write a concluding statement. So we can say, therefore, Giselle needs 110.3 grams of 99% cocoa and 89.7 grams of the 70% cocoa. Remember that our chocolate weight was measured in units of grams, so be sure to include those units in your final statement. The last problem is very similar to problem number 3. It requires you to work with percentages. Sally has $10,000 to invest. She invests in a term deposit paying 5% per year and the remainder in Canada savings bonds paying 3.5% per year. At the end of the year, she has earned a simple interest of $413. How much did she invest at each rate? So if you'd like to give this question a try, hit the pause button, see how far you can get into your solution, and then when you're ready, come back to the final worked out solution. The first thing you need to do is identify your variables. And in this particular question, there are 2 different types of investments that Sally is looking to invest her money in. One is a term deposit that pays 5% per year, and the other type is a Canada savings bond that pays 3.5% per year. So the 2 different types of investments are going to correspond to your 2 different variables. So I've decided to let X represent the amount of money that Sally is going to invest in a term deposit, and let Y represent the amount of money that Sally is going to invest in the Canada savings bond. We don't know what those exact amounts are, so that's what we're trying to solve for. But what we do know is that together, the amount that she invests in the term deposit plus the amount that she invests in the savings bond, that has to equal a total of $10,000. That is the amount of money that she has on hand to invest with the bank. So that is going to correspond to equation number 1. Equation number 2 is where we're going to work in the percentages that were given to us in the question. So in regards to the term deposit, the term deposit pays off at 5% per year. So we don't know how much money Sally is going to put into that term deposit, but we know the bank is going to give her back 5% a year. So 5%, again, we can't use it as a percentage. We have to turn it into a decimal value. So 0.05 is that decimal value. So 0.05 times X plus we have an amount for Sally that she's investing into the savings bond, but that savings bond is going to pay back 3.5% per year. So 3.5% written as a decimal is 0.035. Now, those amounts put together, that is going to equal or total up to the amount of simple interest that she will earn at the end of the year. And the question tells us that at the end of the year, Sally can expect to get a total of $413 in interest from the bank, from her total savings. So that would correspond then to equation number 2. Again, equation number 2 has some decimal values, and I don't think it's a smart idea to work with elimination when you have decimal values. You totally can if you really like the method of elimination, but to keep things simple, I'm going to use substitution again to solve for x and y. So I'm going to go ahead and rearrange equation number 1, and I'm going to choose to isolate for y. So if I bring over the x, that's going to leave me with an equation of y equals 10,000 minus x. And that is going to be called equation number 3. So now I'm going to go ahead and solve for my missing variables by subbing equation 3 into equation number 2. So if you're ready, you can go ahead, pause the video, work out your own solution for both x and y, and when you're done, you can come back and check your final answer. So here's the full solution for the x variable. So I substituted equation 3 into equation number 2. I follow the distribution property, and I simplified by collecting like terms, so I blended together 0.05x minus 0.035x, which gave me 0.015x. I collected like terms by bringing the 350 over to the right-hand side. I simplified, and I isolated for x, which gave me a value of 4,200. I then chose to take my x value and substitute it back into equation number 3. And so by doing that and isolating for y, I got an answer of 5,800. And so now we're ready to write our final concluding sentence. So we can finish off by saying, therefore, Sally invested $4,200 in the term deposit. Remember, term deposit is what we associated with our x variable, so it has to match up to our value for x. So she invested $4,200 in the term deposit and $5,800 in the savings bond.